Good morning students, welcome to my channel. Today we are going to study real numbers and I have decided to take 10 important problems from each chapters and I have decided to give revision in that problems so that you will get at least 60% in your board exams. So we'll do the first problem. Let A equal to P cube, Q power 4, B equal to P square, Q cube. If HCF of AB equal to P power M, Q power N and LCM of AB equal to P power R, Q power S, then M plus N into R plus S equal to what? Actually first you take A equal to P cube, Q power 4 and B equal to P square Q cube. And what is HCF of A and B? You can take HCF of A and B is the smallest power of P. P cube and P square, the smallest power is P square. Q power 4, Q cube, the smallest power is Q cube, right? LCM will be the largest powers, that is biggest power numbers you have tried. If you take P cube, P square, P cube is the biggest one, so you have tried P cube as LCM. Q cube, Q power 4, Q power 4 is the biggest, right? Now, here they have given HCF of A and B is P power M and Q power N. From this we know that M equal to 2, N equal to 3, right? M equal to 2, N equal to 3, right? And here LCM of A and B is P power R and Q power S, right? So what is R? R equal to 3 and S equal to 4, right? Now you apply it here. M plus N, 2 plus 3. M plus N is 2 plus 3. R plus S is 3 plus 4. So 2 plus 3 is what? 5 into 3 plus 4 is 7. That is equal to 35 is the answer. Is it clear? So the answer is 35. Right? Okay. Now we'll go to the next problem. The next problem, the sum of exponents of prime factors in the prime factorization of 1764. So we'll do prime factorization of 1764. So we'll do it. 2, 8 2s are 16, 8 2s are 16, 2 2s are 4, then 2, 441, then 3, 1s are 3, then 4s are, 7s are, then again 3, you will get, what you will get, 3, 4s are 12, 9, 7, 7s are 7, 1s are, right? So you will get 1764 as, so 2 power 2 into 3 power 2 into 7 power 2, right? And they are asking the sum of exponents. So what you will get? 2 plus 2 plus 2. What you will get? 6. Exponent alone you have to add, right? Okay. Shall we go to the next problem? The next problem is find the LCM of smallest 2-digit composite number and smallest composite number. So what is smallest 2-digit number? Smallest 2-digit number is 10, right? You see 10 is a composite number. Yes, it is a composite number, right? And smallest composite number, and smallest composite number you all know that smallest composite number is 4. Smallest composite number is what? 4, because 1 is neither prime nor composite, 2 is prime, 3 is prime, it is neither prime nor composite. So 4 is the smallest composite number, right? Now we have to find out the LCM. When you find out LCM, you take like this, 2s are, 5s are, 2s are, here itself they are co-prime, so multiply 5 2s are 10, 10 2s are 20. So the LCM is what? 20 is the answer. Is it clear? Shall we go to the next sum? Explain whether 3 into 12 into 101 plus 4 is a prime number or composite number. So here they have given, it's a very important problem, 3 into 12 into 101 plus 4, right? From this 12 I can take 4 out, right? When I take 4 out, what I will get? 3 into 4 into 3 are 12, right? 3 into 101 plus 1, right? Now when you multiply 3 4s are 12, you will get 1 4s are 4 will get. See, the above number has 4 as its factor other than 1 and the number. 1 and the number. Therefore, it is a composite number. It is a composite number. Is it clear? Shall we go to the next problem? Fifth problem. When you take fifth problem, check whether 4 power n can end with digit 0 for any natural number. So, here you understand a digit to end with 0. For example, you would take smallest digit 10, right? And what is the prime factor of 10? 2 and 5. 5 ones are, right? Prime factor of 10 is 2 into 5, right? What is the prime factor of 4? 2 2s are 4, 2 ones are. So, 2 square, right? So, I can write 4 power n as 2 power 2 the whole power n, right? And the number to end with 0, it should have the factors 2 and 5. Whereas 4 has only 2 as its factor. Hence, 4 power n cannot end with 0. Shall we write this? So, the number to end with 0 should have 2 and 5 as its factor. Where 4 has only 2 as its factor, not 5. Hence, 4 power n cannot end with 0. Is it clear? Shall we go to the next problem? So, taken 6a, b and c. What is a is? Prove that root 5 is an irrational number. First, let us assume root 5 is rational. When it is rational, we can take root 5 equal to a by b, where a and b are integers, b is not equal to 0, a and b are co-prime. Now squaring on both sides. So root 5 square equal to a square by b square. So 5 equal to a square by b square. This b square will go over here. B square equal to a square by 5. Here we are writing 5 divides a square. Therefore 5 divides a. 5 divides a. Now I am going to assume a equal to 5c. A equal to 5c. Now b square equal to 5c the whole square by 5. So what I will get? I will get 25c square by 5. So I will get equal to 5c square. Here I can write this c square will be here. So b square by 5 I can write, right? Here I can write 5 divides b square. 5 divides b square. Therefore 5 divides b. 5 divides b, right? Now here first we have assumed a and b are co-prime, but here we are telling that 5 divides a and 5 divides b. Now what happened? 5 has become the factor of both a and b, right? So this contradicts our assumption that a and b are co-prime. This contradiction occurs due to our wrong assumption that root 5 is rational. Hence root 5 is irrational. Now 5 divides both a and b. So a and b are not co-prime, but we assumed a and b are co-prime. This contradiction occurs due to our wrong assumption root 5 is rational. Therefore root 5 is irrational. Okay. Shall we go to the next problem? Next problem, given that root 3 is an irrational number, prove that 5 plus 2 root 3 is an irrational number. This can be solved in two ways, right? First, you take 5 plus 2 root 3 equal to a by b. 5 plus 2 root 3 equal to a by b. So for a and b are integers, b is not equal to 0, a and b are co-prime. Now 2 root 3 equal to a by b minus 5. Take LCM. 2 root 3 equal to a minus 5b by b. Now root 3 equal to a minus 5b by, this 2 will come here, 2b. Here you see this side what you are getting, irrational. But here you have proved it is rational. But in the middle you are having equal. This contradiction occurs due to our wrong assumption that 5 plus 2 root 3 is rational. Therefore 5 plus 2 root 3 is irrational. Here I can take another method, second method. They have given already root 3 is rational, right? First 5 plus 2 root 3, you take 2 root 3, this is rational into irrational. What I will get? Irrational, right? Okay. Then 5 plus 2 root 3, 5 is, you know that, rational plus irrational, I will get irrational. Therefore 5 plus 2 root 3 is irrational. Is it clear? This method also you can do more. 2 into root 3, rational into irrational, irrational. 5 plus 2 root 3, rational plus 2 root 3 is irrational, equal to irrational. So 5 plus 2 root 3 is irrational, right? Now next, prove that root 2 plus root 3 the whole square is an irrational number, given that root 6 is an irrational number. First you apply root 2 plus root 3 the whole square equal to a plus b the whole square, right? What is a plus b the whole square? You will get a square plus 2ab plus b square. So root 2 square plus 2 into root 2 into root 3 plus root 3 square. So root 2 square is what? 2 plus 2 root 6 plus 3. So what I will get? 5 plus 2 root 6. Again we have to do like this. 5 plus 2 root 6 equal to a by b, where a and b are integers, b is not equal to 0, a and b are co-prime. That and all you have to write, right? Then 2 root 6 equal to a by b minus 5. 2 root 6 equal to a by b minus 5b by b. So 2 root 6 equal to a minus 5b by b. This 2 will come. So root 6 equal to a minus 5b by 2b. Okay. So here you understand this side, this is irrational. They have given already root 6 is rational. Here we have proved rational, middle equal to, again we have to write this contradiction. Irrational equal to rational is not possible, right? So this contradiction occurs due to our wrong assumption that 5 plus 2 root 6 is rational. Therefore 5 plus 2 root 6 is irrational. Is it clear? Shall we go to the next problem? See here, assertion the HCF of two numbers is 9 and their LCM is 2016. If one number is 54, then the other number is 336. First we will check, right? You know that HCF into LCM equal to number 1 into number 2, right? This is very, very important formula you have to understand, right? HCF is 9 and LCM is 2016 and one number is 54 and we have to find out another number 2, right? Okay. So here you write number 2 as such. So 9 into 2016, this 54 will come down, right? And cancel 9 ones are 9 6 are, and 6 and 2016, 3 6 are 18, remainder 21, 3 6 are 18, remainder 36, 336 is correct. And we have applied this formula only, right? Hence assertion A, option A is the answer, right? Option A, that is assertion, both assertion and reason are true, and reason is a correct explanation of the assertion, right? Now shall we go to the next one? Okay, using prime factorization method, find HCF and LCM of 96 and 120. It's a simple problem. We'll do 96 prime factorization. We'll do with 3, 30, 2, then 2, 16, 2, 8, 2, 4, 2, 2, 2, 1. 120, 2, 16, 2, 30, 3, 10, 2, 5, 5, 1, right? Okay, now HCF means write 96 prime factor, 2 into 2 into 2 into 2 into 2 into 3. 120 prime factor. What are the prime factor? 2 into 2 into 2 into 3 into 5, right? While writing the prime factors, write it in the ascending order, it will be easier, right? So HCF will be the common numbers, common factors, right? 2 into 2 into 2 into 3, right? So 2 2s are 4, 4 2s are 8, 8 3s are 24 is the HCF, right? Okay, now for 96 and 120, you have to find out LCM means what you have to do. 96 and 120, first divide by HCF. This HCF will divide, right? Then we'll see. 24, 4s are 5s are, right? Okay, now here itself we can know both the numbers are what? Co-prime. So LCM will be 24 into 4 into 5. So 24 into 4 5s are 20. 24 2s are 480 is the answer. Is it clear? So shall we go to the next problem? Two numbers are in the ratio 2:3 and their LCM is 180. What is HCF of those numbers? See here, if it is ratio means take the numbers as 2x and 3x. Find LCM of 2 and 3. You know 2 and 3 are prime numbers. So the LCM will be 2 into 3, that is equal to 6, right? So now I can write LCM of this is 6x, right? 6x equal to 180, right? And x will be what I will get, 180 by 6, that is equal to 30, right? Now we can find out that numbers. 2x means 2 into 30, that is equal to 60. 3x means 3 into 30, that is equal to 90, right? So now we have to find out HCF. Factors of 60, HCF we are going to find out. Prime factor of 60 is 2, 3s are 6, 2s are 12, 5s are 60, right? For HCF of 90, 3, 3s are 9, 9, 5s are 45, 2s are 90, right? Okay, now HCF will be common 2, right, into 3 into 5, right? 2 3s are 6 5s are 30 is the HCF. Is it clear? So the answer for this is what? The HCF of those numbers is 30, right? Shall we go to the last problem? The HCF of 65 and 117 can be represented as 65n minus 117. Find the value of n. First we'll find out 65 and 117's HCF. You know that 65 is divisible only by 13. So when you take 13 5s are 13 9s are, you will get both are co-prime. So 13 is HCF, right? So I can write 65n minus 117 equal to 13 because they told that this can be represented by their HCF, right? So 65n equal to 13, this minus 117 if it comes that side plus 117. 65n equal to 30. So n equal to 130 by 65, that is equal to 2 is the answer. So n equal to 2 is the answer. Is it clear? You just read the book fully and what is that introduction they have given and what are all the example problems you practice and exercise problems fully you practice. Then you practice the remaining 10 problems which I have done it here. Definitely you will get 60% in your board exams if you practice all these things thoroughly. Thank you, students.